Engineering mathematics question based on vectors and matrices. We are having two n-dimensional real vectors P and Q such that an operation S has been defined on them, which is given as S of P and Q is sigma of P of I dot Q of I. So this operation is nothing but the dot product of two vectors. And for every possible pair of P and Q, we'll be performing this operation on every dimension one at a time. It is an n-dimensional space, so from I going from 1 to n means in every dimension we are taking the dot product and then we are summing them up. So given this operation, we are having a set L, which is a set of 10-dimensional non-zero real vectors, which basically means that we are having a 10-dimensional space, and for that there are corresponding vectors in that, such that for every pair of distinct vectors P and Q in this space L, which means from this 10-dimensional space L in which we are having a set of those 10 non-zero real vectors, we are taking up two vectors at a time represented as P and Q such that their operation S of P and Q gives 0. Now S is nothing but a dot product as we just saw. So when do we get the dot product of two vectors are 0? When they are mutually perpendicular. So from this 10-dimensional space, from those 10 vectors, we are picking up two vectors at a time such that they are mutually perpendicular. So basically we need to find the number of such mutually perpendicular pairs which are possible. And what's the maximum cardinality for this set L? That would be the same. If we are having a 10-dimensional space, then there would be 10 different ways in which we'll make such combinations possible, and those 10 vectors taken up two at a time will be forming the mutually perpendicular pairs. So in the resulting set L, its cardinality would actually represent the number of such mutually perpendicular vectors we could find out, and that is, as we just saw, is 10. Hence cardinality for this set has to be 10. That is our answer.